Hi, welcome back to Engineering Drawing. I am your Dr. Vasu. Hope you are enjoying the lectures so far you have seen. If you want to learn this and many more interesting topics, please do subscribe this channel. If you like this video, please hit the like button. That will keep me motivated to create more such videos. Now let's see what these Vernier scales are. Very interesting scales these Vernier scales are. Here, using this scale, we can show third dimension also. Like we have shown a third dimension in the diagonal scales. Here also, third unit is also possible. Let us see the principle, how it works. Suppose I have taken some length. It can be a line, but to be more clear, I have taken a rectangle. So we have divided this into some 10 equal parts, right? Each division is showing 1 centimeter, suppose. Now, I will extend 1 unit extra on the left side. That is, this is 1 unit. So, 1 unit is extra. That is 11. This entire length indicates 11 centimeters. Now, on top of this, I take another rectangle here of the same 11 centimeters size. 11 centimeter size. I have taken a rectangle. I will divide this into 10 equal parts now, right? 1 to 10, 10 parts. What happens? This is actually 11 units length, 11 centimeters. When you divide this into 10 equal parts, each division will be 1.1 unit. So I mark this 1.1 like this, 1.1, 2.2, 3.3, up to 11 centimeters. So this is entirely 11 centimeters here also. Now, if you observe, this 1.1 is here and 1 is here. Okay? If you draw a line here at 1.1 and through 1, there's a small gap here. This gap is nothing but 1.1 minus 1, right? This is 1.1 and we are subtracting, we are removing this 1 unit, 1 centimeter. That means the small gap here is 0.1 unit, 0.1 centimeter. That means if you take 1 unit here, 0.1 unit you get it here on the Vernier scale. This is called Vernier scale. So like this, we can get the next unit also using this Vernier scale. Now let's apply this to the principle, to the scales, and let us see how they are drawn. Suppose you are asked to draw a Vernier scale, RF is given, and the maximum length is also given 4 meters. And let's calculate. RF is given, maximum length of the scale, RF into maximum length in centimeters, 16. So 16 centimeters long line we are drawing here. And how many parts we divide this? Because this is indicating 4 meters, divide this into 4 equal parts. So we get 4 equal parts here. And each division here represents 1 meter. This is also 1 meter. Now let's divide this 1 meter into 10 equal parts. Okay, mark them as this is 1 meter. So what happens? This is 0.1 meter. Right? So we indicate 0.1, 0.2 like this up to 1 meter. So these are all meters, 0.1 meter like that. Now on the left side, we extend this by 1 unit. This 0.1 extra. So this 0.1 extra is indicated on the left side. So this from here to here, this is 1.1. Already 1 here. This is 0.1, 1.1 totally. Now this entire 1.1 meter is now divided into 10 equal parts. And so the 10 here. So 1.1 by 10 is equal to 0.11. Let's mark this 0.11 here. So this is 0.11, 0.22, 0.33. These are all meters again. Now, suppose I have drawn a line here at point 11 and 1. What is the difference, a gap between these two lines? 0.11 and 1. 0.11 minus 0.1 is 0.01. That means we are able to measure second decimal also, that is second unit also. Okay, so this 0.1 means decimeter, actually 1 decimeter. 0.01 means centimeter, right? That means we are able to measure meters, here decimeters and centimeters also. Now let us see how the lengths are shown on this Vernier scale. Suppose I want to show 1.82 meters. Okay, and here you can take the intermediate, these divisions also to show the given lengths properly. Okay, now we have divided this into 10 equal parts, each meter. Now 1.82, I want to show 1.82. Let's divide this into 0.22 plus 1.6. Because 0.22 is readily available here, right? In this, basing on the second decimal place, I have taken this 0.2, right? 0.22, 0.22 and 1.82 minus 0.22 gives 1.6. So these two sum up together 1.82. Now 0.822, I draw a line here at 0.22 and also another line at 1.6, 1.5, 1.6. So draw a line. So this distance is 1.82 meters. Now 2.39, same, basing on the second unit here, second decimal place, 9 is available, right? 9. Where is the 9 here? Here it is. So 0.99, we take 2.39 is divided into 0.99 plus 1.4. These two put together, we get 2.39. So 0.99, we draw a line at 0.99 and 1.4, 1 and 1.4. So draw a line here. This line indicates 2.39 meters. Okay. Similarly, 0.73, take 0.73. This is again basing on the second decimal. We get where is 3 in the second decimal place? Here. So 0.33. Let's divide this 0.73 into 0.33 plus 0.4. This is 0.73. Now 0.33, draw a line here, and 0.4 from 0, here it is 0.4, right? So draw a line, this is 0.73 meters. Similarly, 0.48. This 0.48 means 8 is in the second decimal place. So let's take 0.88 minus 0.4 gives this 0.48. We need only 0.48. So 0.88 means it's more than this. So subtract 0.4 and now you get 0.48. So draw a line here at 0.88 and another one at 0.4. So this gap is, this distance is nothing but 0.48 meters. So like this, we can show the second decimal place also. Another one, here the areas are given. We need to calculate the RF and we are asked to show kilometers, hectometers and decameters. And maximum length is given. Let us see how. So take the square root and the representing value, area and the original area, right? Convert them into same units, right? Centimeters, square centimeters here, and cancelling the zeros, simplifying it, you get it. Get the square root, we get this as RF. So this is RF. Maximum length 7 kilometers, right? And length of the scale, RF into maximum length, you get 14 centimeters. So we draw a line at 14 centimeters long and construct a rectangle here. Divide this into how many? 7 parts. 7 parts. So each part, each division represents 1 kilometer. So take this is 1 kilometer And now these are showing kilometers. Okay. Now this is again 1 kilometer. Divide this into 10 equal parts. We get 1 by 10 means 0.1 kilometer or hectometer, right? Hectometers. So no need to write any point. This is hectometer. 1, 2, 3, 4 like this. 10 hectometers. We got it. Now, next we need to get decameters also. So further we need to extend by taking 1 unit on the left side, right? The same length on the left side here. 11th, this one. That means 11 hectometers. This becomes 11 hectometers. This 11 hectometers is divided into 10 equal parts like this. And 11 by 10. Because this is 10 divisions, 11 by 10 means 1.1 hectometer. This is 1.1 hectometer. Okay, mark it. 1.1, 2.2, 3.3, 4.4 like this, up to 11. But here if you observe, this is 1.1, right? This is 2.2, this is 1.1. 1.1 minus 1, right? This is 1. So the gap between these two is 0.1 hectometer or 1 decameter. Either it's a 0.1 hectometer or 1 decameter. Now we got it. So we are able to measure decameters also. That's why in this units you are given 0.59 here, right? Now let us see. Divide this also into 10 divisions. Each kilometer is divided into 10 kilometers so that it will be convenient for us to measure the required lengths. Now, 0.59 is given, 0.959 decameters. That is, we take 0.99 minus 0.4 gives 0.59, right? This 0.59 here. So, draw a line here at 0.99 and 0.4 here in the bottom scale. The distance between these two is nothing but 0.59. Okay. Now another one, 5.33. Again divided into 5 plus 0.33. 0.33 is readily available here. So at 0.3 we draw a line and 5 we draw another line. This length is 5.33. Okay. So like this we draw the vernier scales. We can take another example. A length 500 meters is represented by a line of 15 centimeters on drawing. So we can calculate RF easily, directly. RF here can convert into same units. This is RF. Take the maximum length, right? Actually, maximum length is 600 meters is given. But if you take 600 meters into this RF, you get decimal places. So for convenience sake, we have taken 700 meters. Now, convert this into this one, length of the scale, you get 21 centimeters. Draw a line of 21 centimeters. Divide this into how many? 7 equal parts. We divide into 7 equal parts here, and each one is indicating 100 meters. Okay, 100 meters here. Now divide this into 10 equal parts. You get 10 meters each. This is 10 meters like this. Extend this by 1 unit, right? 1 division extra, and this becomes 110 meters. So this 110 from here to here, divide this into 10 equal parts. This is 110 meters by 10, right? How much? 11. 110 by 10, this is 11. So here we get 11, 22, 33, 44 like that. So 11 minus 10, that is 0.1. 11 minus 10, 1. So we get 1 meter here. So it need not be actually this 100 meters means actually you can write hectometers. This is hectometers. and decameters and meters, like that. Instead of hectometers, we have shown hundreds of meters. That's the difference. So here we are able to show 3 units on this. Now, let us indicate a length of 549 meters. This 549, divide this also into small divisions. 549 means 0.99, right? We take 549 is divided into 0.99 plus 450. That is 549 meters. So like this we get it. And another length also you can show, that is, suppose you want 35 meters. We have readily 55 meters available here. This is 55. Okay. 55 minus 20. This 20 is taken in the bottom scale. 55 minus 20, that is 35 meters. Okay. So like this, you can show any length. And also another example also, you can see, construct a Vernier scale of RF given 4 meters, calculate length of the scale, and here divide it into 4 parts, meters, and here divide it into 10 equal parts. We get 0.1 meter like this, and extend this by 1 unit, that is 1.1 meter, divide it into 10 parts. You get a 0.11, 0.22 like that. And here, suppose I want to show 0.28 meters, that is 0.88 minus 0.6 gives 0.28 meters. So 0.6 is taken in the bottom scale, 0.88 on the upper scale. The gap is, this length is 0.28 meters. Similarly, 2.34 is indicated as 0.44 plus 1.9, that is 0.44 plus 1.9 here. So this is the 2.34. 3.14. 3.14 means 2.7 plus 0.44. So 0.44 already we have a line. 2.7, 2.5, 2.6, 2.7, and draw a line here. This is 3.14. 0.21. Here it is. It's interesting again. 0.21 is taken as 0.11 plus 0.1. Okay. So at 0.11, we draw a line here, and 0.1 plus, that means on the right side. So 0.1 here. So join these two, you get 0.21 meters. Okay. So hope you understood these Vernier scales very clearly. And if you have any queries or suggestions or any doubts, please do comment below and do subscribe to the channel. Thank you very much.